Hi, let us solve one problem from electronics of TIFR 2025 question paper. So the problem states that consider the collector emitter characteristics of a silicon NPN transistor in the figure below. The circuit on the right is for lighting a LED with an input voltage of Pin equal to given as 1 volt. The LED needs 20 milliampere current that will be provided by the transistor. A forward bias silicon PN junction has a 0.7 volt drop across it. So what is the closest value of the resistor RB needed for this purpose? So we need to find the value of RB, right? So we have V in equal to 1 volt. We have we have V in equal to 1 volt. LED current, LED current, LED current equal to 20 milliampere. EBE, EBE 0.7 volt forward bias, forward bias, forward bias, PN junction. So from the graph, we see that from this plot, we see that IB equal to 200 microampere and IC is almost equal to, we have from the graph, it is seen that IB equal to 200 microampere and IC is almost equal to 20 milliampere. Therefore, to achieve IC equal to 20 ampere, 20 milliampere, we need IB equal to 200 microampere. To achieve IC equal to 20 milliampere, we need finding RB. We need to find this resistance RB, right? So the base current comes from V in through RB into the base emitter junction. So we can write that V in equal to IB into RB plus VBE. Right. So we can write V in is given 1 volt into 200 into 10 to the power minus 6 ampere RB plus 0.7 volt. We solve for RB. So we have 200 into 10 to the power minus 6 into RB is equal to 1 minus 0.74 equal to 0.3 volt, right? So RB we will get RB equal to 0.3 divided by 200 into 10 to the power minus 6. We will have 1500 ohm. 1500 ohm, right? So 1500 ohm corresponds to 1.5 kilo ohm. Right. So from the above equation or the above options, the option A, that is showing 1.3 kilo ohm, is correct. So the option A of the given problem or the given uh, problem is correct. Hope the problem as well as the solutions are clear. So thank you.